Hey guys, hope you had a good weekend and a good midterm and all. Yeah, great, great. Um, yeah, so well, we're gonna wait for other people to turn up. Um, I had an idea. I had an idea. Maybe we can try it out today. Okay, you know, playing with objects and all. So I thought we could have two groups. Well, we'll see if it works, okay? We're going to have two groups of students because I think one time before we tried to split up into multiple groups of students, and then I think we gave up on that, right? Because of Zoom issues or breakout, something like that. Or all right. But this time, um, let's have two groups, or multiple people, right? Individuals even, that's fine, right? Multiple groups, multiple people. Each one might could create an animal, okay, called animal in a file called animal.cpp. So only you know what the animal is, and nobody else knows what the animal is. But you can program the animal to respond to a fixed set of questions anyone can ask, right? I mean, we can come up with some questions like, how many legs do you have? Or, do you swim? Do you fly? And things like that. Maybe, 50 or 60 questions like that. And then each person that implements the animal has to implement these things, these little functions. And then they compile the code, and we can take that opportunity to introduce something that's slightly outside the syllabus and the scope of C++, but I think will be useful for you, is to basically just compile it, not all the way to an executable, but to an object file, okay? Do you know what an object code file is as compared to an executable? Because they're both machine instructions, right? At the end of the day, they're both raw machine instructions. Just remind me to talk about this afterwards, right? When we're linking these things together, and then the whole damn thing will make sense, right? Because then we talk about previously, right? We talked about linker errors and unresolved externals and globals that, are declared here, but not defined here, and so on and so forth, and linker. And we talked about all these issues, and a whole family of compiler generated errors will just start making sense. Because once you know the whole process, right, the end-to-end process, then you can look at the message that the compiler spits out at you, and you can place the message in the place from where it came, right? That is really the most important part of deciphering any message whatsoever, right? Whether it's human or a computer generated, the most important, point is to take the message and find out whether it came from the part that links methods together, or did it come from the part that analyzes syntax issues, right? Or is it the translation of syntax? All these things, right? Or runtime errors. So this is all these families of errors. And I think, trying to recognize these errors as which family they fall into, I think is really super duper important. And we can find out once you know the end-to-end process, then you'd be able to place these error messages really quickly. I think it's really like, exponential search, right? Logarithmic search, because you start off and then almost, subconsciously perhaps, right? These, when you see something, it just gets binned into a whole, a number of discrete categories, intervals of, search space maybe. And I think, and how do we know where it goes, where this fits in? And I think that getting the full picture end to end, you typing it on the keyboard in ASCII in a way that humans can read, all the way out, right, into, and I think that's really cool. Yeah, we can do that today. Yeah. So where I was going with that is that you'll create these object files and then share these object files, right? In fact, maybe you all put the object files into a bin, right? So animal1.cpp, animal2.cpp, nobody can look in the CPP files. No, actually animal1.o, we're going to talk about object files. So even if you look inside the, right? So nobody's going to look inside of the object file. So you have a whole bunch of animals in a directory or a folder. And then your job will be to write a main that will basically just interact with a randomly chosen animal.o file and determine what the animal is by asking it all the right questions, right? And then you could code a method saying, "Are you a rabbit?" And if the answer is yes, it'll say yes. But if you only get one chance, maybe one crack at "Are you a?" Right? And you can ask a whole bunch of clarifying questions before then. But so you can turn this into a game. So people can just pick random object files and try and determine what the animal hidden inside the object file is. You know what? This I think turned out to be a much better version of what I was thinking about. Right. Previously, I think I was thinking about two teams and one, and this team trying to discover what the other team's animal is, like names, places, animals, things. I don't know if you've ever played that game as a kid. But back in the day, before the day of age of computers, the names, places, animals, things is, or one of the zillions of versions of it, right? Variations is a very interesting game that you guys can actually try and implement in C++, right? Maybe take that on as an extra credit project and someone implement it and share it. It's interesting enough, right? Lots of people, C++ in CS2A, DC may start using it, and you may get loads and loads of extra credit, right, for doing something like that. So how about this? I think this is eminently doable in C++. You have to design it, right? Maybe a group of you get together, right? And then design this game, how you're going to implement it. Names, places. Does anybody know what the rules of names, places, animals, things is? Let me try and remember, right? I think you pick one of the categories or something like that. And no. In each round, every person writes a random name, a random place, a random animal, and a random thing, or something like that. And then at the end of the round, you tally, and anyone who's got a duplicate is that's gone, right? Only the unique ones get points, or something like that. And so you actually get a lot of points by thinking out of the box and thinking about things that other people don't think about. And obviously the game is not much fun with only two people, but I think if you play with a group of 30 or 40 people, which I think I used to, no, I think the biggest group I've played with is maybe 8 or 9 when I was a kid, 8 or 9 people. And even then the game was very interesting because, you find that people tend to think of the same kind of things. And then when they try to become very I'm not going to think about the same kind of things, I'm going to think of something completely different, everybody's trying to think of the same completely different thing too, right? So it's very interesting just to watch the game. The meta game itself is actually a very interesting thing to do. So I think that can actually be coded up in C++, where you guys can get together and design a way in which this can work as a program. Either the program can just be a mediator, where it takes all the choices generated by humans and then gives points out by crossing out the dupes, which is pretty straightforward. Or you can inject the computer, the CPP, your program as another player, right? And given a 4 files or four bunches of things, names, and it's going to pick random things out of there, something like that, right? And so you can do those things, and I think it's really cool. And obviously, if you do that, I'm telling you right now, okay? So these are the cool kind of things that will get you lots and lots of points in CS2A, right? Not just, obviously you can get an A+ by acing all the quests, being participative on the forum and in class, and exams and midterm and all those things. But a surefire way to get an A+ in any course, right? Not just CS2A or my course. Is really to just take something in the field that is relevant and just do a really cool and interesting job that all students are excited by, right? And even the teacher loves, right? And in fact, I've already told you, right? This will be a really cool game if one of you implements it and posts it. I can show you how to do it in JavaScript afterwards, right? After you've got the logic down in C++, and show you how to do it in JavaScript as a web app. So you can just put it out on the web and have people play. Right, online, the computing is being done on their machine. You don't have to worry about server and backend and all, right? Because in JavaScript, their Chrome is going to do the computing. So, but once you get it down in C++, I can show you offline, meaning not in CS2A time. Maybe over the holidays, right? Yeah, an hour or so. I can show you over Zoom how to turn that into JavaScript. But you got to show me that you can, you've got a working C++ version. How about that? Is that a good challenge? If you get a if you got a working C++ version, I'll give you lots of points for CS2A. As long, I mean, not like lots, you'll get lots and lots of points depending on the quality of the product, right? So if you've done a really good job and thereby demonstrating in what you've created that you actually understand everything that the syllabus is about. Right, so you understand about the basic mechanics and the control structures. You know about memory and things like that. You know about arrays and you know about classes and you know about methods and how to call each other. So all of that is embodied in this program. And if that program shows that, then you basically just that is like a professor is totally happy with that, right? Because that is our goal, right? At the end of the day, whether this is explicitly a requirement in the course or not, this is what all the professors are shooting for, is to have you excited enough about the subject so that you go ahead and do something without us having to push you, right? So without saying that there's points hidden here, without saying there's credits and exams, and you've got to do this for the exam. If one of you basically just says, I'm actually interested enough about this, I'm going to go and try and do something. And then you show this to your classmates and your teachers. I'm pretty sure everybody will be super duper happy. Okay. So yeah, so that's one of the ways in which people can actually get A+ in any course, right? Even if they've been, you got to be participative, of course. I'm not talking about the participation points. I'm talking about the concept and the implementation points, right? So if you've taken a project that involves a good grasp of concepts as well as implementation skills, that basically means that you've aced, right? By demonstrating that that means you've aced your non-participation side of things. That makes sense, doesn't it? Right? I'm going to evaluate it, of course. I mean, it's not just that everybody who takes a crack, but I will absolutely be happy to evaluate it, and obviously it's all extra credit, right? You're not going to lose any points by attempting. So it's worth a shot if you have time, right? If you have time, you can devote it to this. And today we'll try and implement a class. Is everybody here? I think yeah, it's about 8:15. Can we basically start? You guys want some time to talk until 8:30? Do you guys want to talk amongst yourself until 8:30, and then we can start at 8:30? Because I mean, I'll tell you what we're going to talk about today. We'll talk about classes, and then we'll develop a class called Animal, which basically will be the starting point of whatever you may decide to do. And in the Animal class, we'll just stick in a whole bunch of we'll try and get to that place, okay? And then I'll hand it off to you in a place where you will feel comfortable hacking, okay? So so I'm not going to just drop you off the ledge or something like that. So yeah. So we'll get classes. We'll build up to classes and get to a place where you can implement classes. And at that point, I'll basically just step away and just watch you guys code. Hey, Yang Yuxin. Hey, Yuxin. Can you hear me? Hey, Yuxin. Okay, can you see him? Can you guys see him? Can someone reach out to him? Okay, so I can see him, but is he frozen? Is that a photo? Is the connection broken?
He might be frozen.
Yeah. Okay. All right. So he was going to code today. All right. Well, you guys can figure it out at some point. By the way, is everybody okay with the midterm and the things that we've been talking about in class? Do you have any questions? Do you have any concerns? We can talk a little bit about meta aspects of the class if you like, for about 5 more minutes, until at least Yang Yuxin comes back online, maybe. Hey, Fernando, are you here today? Okay, all right. So the 2 people are either frozen or something's happened to these lines. So you guys have to reach out to them, and I'll try and reach out too. But obviously, if you're on Discord or Slack or something like that, you should tell them to get in touch with me. Do you have any questions? Any other course related questions? Anything about the midterm or quest so far? Is everybody happy with all the quests you've done? Yeah. By the way, if you finish quest 9, you can go all the way back and polish up any quest in from 1 onwards. Okay. So if you've lost like a couple of points on quest number 3, and the freeze date is now, right? So you can't get those 2 points anymore. But if you've gone on to 9 and finished 9, you can go back and get those 2 points. Yeah. But 9 is in fact a difficult quest in in CS2A. So I really urge you to the second half of the course starting today to also let all your classmates know that they've got to get serious about this class. Okay, so until now we've just been playing around with control structures, but once we start working on classes, and then we'll start getting the flavor of algorithms, with search and sorting and things like that. And then towards the end we'll start playing with linked data structures, right? And that is the bit that many students will get totally confused by, mainly because if you're not so rock solid, because think about it, as a kid, walking is really hard, but by the time you're a toddler or something, your walking is rock solid, right? So you can try all these other skills like climbing and things like that. But the thing is, you're not even thinking about walking. But if you've never walked in your life, you're going to think that, oh my gosh, I got to learn to walk first, and then I have. So so it's much harder. It's much harder if you haven't gotten the basic skills rock solid by the time you get to pointers. And the reason I say that is because it's very possible to get so familiar with the basic skills that it becomes second nature, right? Because if you want to raise a mug to your lips, you're not thinking about many things, right? You just go and do it. Yes, right. But kids have to do that, right? So Alex, right? So like a cup, right? So it's a cup, not a mug. Yeah. So but many of those things are, yeah, we do it, but we can think back and be conscious about it. And the thing is, it is possible to get the mechanical part of C++ to that level. And a lot of people who start with CS2A don't believe that. I think most people don't believe that. Maybe, right? Maybe they drop out not believing that, because once you get to a certain stage, you will stop believing that, because right? Because it's all become second nature to you. You don't think about for loops anymore, right? Obviously, already you're not thinking about certain basic things, right? Where when you declare a variable and an integer, you're not going to think, right, whether it's going to be a size t or an int or things like. You just know, bam, bam, bam. You just put these things in place, right? Tokens in place. You're not thinking about these things, right? Because it's all becoming automatic to you. And more of these things will become automatic to you. And by the time you're with pointers, the reason why pointers is very challenging to CS2A, CS2A, and also beginning CS2B who haven't done pointers and jumped into CS2B, that's a bad idea, because you can pass CS2A without knowing about pointers. Because you only need to do up to 6. Did I tell you this is formal, right? I think it's in the syllabus. If you do up to quest number 6, you can pass CS2A. So yeah, quest number 6, you don't need to do pointers, and it's just classes, and you'll pass. But yeah, you'll get a C+ or something like that maybe, but you'll pass for sure. But you can't take that pass and say, well, I've passed CS2A and gone to CS2B. Most likely the chances are that person will drop, right? Just because they pass CS2A is not a reason to enroll in CS2B. So you have to get to pointers. And I think that having talked to some of the people who drop CS2A, it seems that many of them think that remembering a lot of things in CS2A is formidable, because there's too many things to remember, and they don't know if they are cut out for that kind of thing. By the time they get to, week 9 or week 10, there's so many things to, because they have to consciously make a choice between, okay, at this point, is it better to use a for loop or a while loop and things like that. And they cannot see themselves making these choices intuitively. But the problem is that they didn't stick around long enough to find out they can do it. So if you stick around in CS2A and actually get to the place in I think week 9, you'll get to a place where you'll be implementing in the Quest 2 certain things, which will basically just require you to pull these constructs off from memory, like off a shelf, knowing, reaching for the right thing at the right time. So you'll be very comfortable. And pointers, it's very important to get comfortable with these things before you get to pointers, because if people have difficulty in dealing with objects that are located in an orderly way, maybe one after another on a desktop and things like that. Now, imagine how much difficulty they would face if the objects were not all neatly located next to each other, right? So one object was here, another object was somewhere else, and the only handle you have on it is what this object tells you, right? This object will tell you, right, that my successor is not next to me, but lives in Ohio, all right? And here's the address, right? And that person says, my successor lives in, New Mexico, right? Or, Tehran. So, and so you have to jump around. So imagine how much more difficult it will be to to handle an algorithm that does that if you're not automatic with these, because you'll also be implementing very quickly, very soon, and not very quickly, obviously, very soon, a data structure that has not just one descendant, but has many descendants, right? If I have one pointer in me saying, oh, well, my next successor is here, but instead I have many successors, and the successors are here, 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 and here. Okay, now each one of those could have many successors themselves. Now imagine what kind of complexity that the algorithm would have to deal with, right? So so those kinds of things we will not find intimidating, right? We'll not find intimidating if these things are just ironed out before we get there. So that's why I say, and pass this message on to all your classmates who are not here today, is to basically persevere, because this is the time, week 6 to week 8. Right, week 6 to week 8 is really the hardest time I think, because you've really crossed the point where you could drop the course with a W. So something like that. Some crazy thing has happened. Some deadline that I don't know, students know, is that you can't drop the course without having an impact on your transcript, and you've got to catch up if you want to pass or something like that, or get a good grade. So and then also and the course gets challenging because we're going to start talking about objects and things like that. So they don't know what to do, but this is the time to basically just focus, right? Just basically focus and say, I'm willing to sacrifice. I'm willing to sacrifice two weeks of fortnight, right? 2 weeks is a fortnight, yes, but 2 weeks of playing Fortnite, right? So and just focus on this, because that is going to be like totally worth it at the end. It will be, I can guarantee, right? I can totally guarantee that it will be worth it. If this is the part, 2 more weeks, okay, 2 weeks, week 8, when you're doing quest number 8, if you're comfortable doing quest number 8, you will be comfortable doing quest number 9. Quest number 8, no pointers, right? No pointers in quest number 8. You're just dealing with arrays. You're just dealing with arrays. In fact, vectors. You're dealing with vectors in quest number 8. Right? And it's just vectors being used in a special way, and which we'll try and do in class. So, but if you can do that comfortably, you'll be okay with pointers. When we talk about pointers, we're not even talking about pointers, right? But we've been building an intuition towards pointers steadily, because we've been saying, right, address of things, right? So this is a thing, and we don't have it here, but we have it there, and so on. Okay, that's basically the concept of a pointer. And when you pass an object by reference, also, again, there's a pointer there, but we don't have to handle the pointer, because the compiler says, right, well, you know what, if you want to modify the actual thing and not a copy of it, then I'll pass the address of the actual thing over, except you don't have to explicitly pass it with the address of operator, which is an ampersand, right? I'll handle everything for you. You just tell me that it's passed by reference, right? So the compiler takes care of the back. So that's a very nice syntactic sugar. It's icing on the cake, right? So it's because it's not just something that's unique to C++. C++, I'll give you syntactic sugar to do something that you could do in assembler anyway, right? So passing by reference is a very nice thing in C++. That's basically what happens. That's how pointers get used. Obviously in C, you didn't have, I don't think we had passing by reference when C first came out. I could check my copy of, I don't know who has my copy, right? So my copy of Koenigan and Ritchie, the yellow book for C. I don't think it had a pass by reference in it. Right. So I think in C, if you wanted to modify an actual structure, because there are no objects in C, right? In C, you only had structures. You'd have to pass the address of the structure, right? You have to pass an address, the pointer of the structure, the pointer to that structure. You have to pass it to a function and say, now I've given you but there was no way of marking it as const, right? So that's the reason why, people complain about C being a sloppy language because it doesn't have these enforcements, right? Like const and object, information hiding, and so on and so forth. Yeah, neither does assembler, right? It doesn't make C a bad language. It makes C a perfect language for people who know how to use it, but it makes C a bad language for people who don't know what they're doing, right? So because it's like assembler, right? You can do a lot of things in assembler. You can do a lot of things even with your computer, right? Say, but we don't do it because we know it'll ruin the computer, or we don't know how to do it properly. So so the fact that C lets you all do all these things is, there's no const tagging in C. Yeah, okay. That just means that newbies shouldn't be playing around with C, right? So if you want a guarded language where you're saying no, don't trust me because I make a lot of mistakes. I haven't learned a lot of these things. I make a lot of mistakes. Just give me a language that'll look out for me all the time. Right. So, but there are languages like that, all the way from one extreme of the spectrum to the other extreme. We have languages, right? So we can choose. So, so C++ falls very nicely in that spectrum, in the place where it gives you a lot of restrictions where you need it, but it also makes it possible for you to remove any restriction you want. Right. Unlike in many other languages where it is much harder to remove these restrictions. Right? And in many cases, when you want to do some really performance-oriented programming, right? So a really efficient programming and cut the CPU corners and make sure your program is right, but it doesn't waste any cycles at all. Then you really want the power of driving the CPU very close to its heart, and C++ lets you do that. Because it's like saying, well, develop a program with all these checks in place that I will give you, but when you're ready to go, production quality, then you can remove these checks one by one, right? And then I can make sure, right? So your program gets thinner and thinner and thinner, and it's so slim that it's very efficient, bounded only by the algorithm efficiency. I think so. That's where C++ is. I think. I don't know. Well, you know what? It's 8:30. What were we going to do? We were going to go code a class together. Yeah, we can do that. Yeah. Initially, I have to walk one of you through this. I think, like we do usually, right? Well, let's pick up the screen and code a class. Code the motivation for a class and turn it into a class, I think, and then I'll hand it over to you guys, and then you can play with it. Okay, you can play with it. You can. I don't know. Can you guys create breakout rooms on your own? Do you have Do you have a thing called breakout rooms at the bottom of Zoom? No, you don't even have breakout rooms at the bottom. Okay, all right. Maybe I'll just create a whole bunch of breakout rooms.
I think only the host can make breakout rooms.
Oh, I see. Well, we'll figure out how to do it. Okay. We'll figure out how to do it. Or you could just, pair up or, join groups and, work offline. It doesn't, or you can just chat. You can chat and then work on your own computers, and we'll figure out a way. Okay. All right. So let's start in 5 minutes, and then unless you guys have any questions. All right. You have any questions? Okay, answer. Fernando and Eugene. Maybe I'll send them chat. Hey, feel free to talk, okay? There shouldn't be any silence. If you have any questions, ask. Otherwise, you say you're ready to code, and then anyone can pick up the screen. Okay, anyone can pick up the screen. I was hoping that Yusin or Fernando will take the screen today, but neither of them seems to be responsive. Okay, so one of you has to let them know. Yeah. Really, if you've lasted this far into CS2A, very likely you will actually make it through to the end. It just may take a little bit more perseverance, depending on all the other classes you're enrolled in. I have no idea, right? See, that's why it makes a whole lot of sense to find out before the quarter starts. And I found out in CS2B, a lot of students just enroll in CS2B without even reading the syllabus, right? And they just say, well, I need to enroll in a CS2B this quarter. Do we have any free sections? Okay, there's one. I'll put my name there, right? That's not the way to enroll in classes. And then you know, a lot of students enroll in too many classes, and then maybe that's even not the problem. They don't decide which classes to drop until it's very late, right? As long as you enroll in like even if you enroll in many classes, if you make up your mind in the first 2 weeks and then say, I'm going to dedicate myself to these 3 classes, that's okay. Because otherwise, this week and next week, I think is really, really hard for many students. Just stick around. And I'm pretty sure we have a lot of support, okay? A lot of support, STEM Center, and your classmates too, and I'm here, okay? Nobody wants to take the screen? How about one of you, anyone, okay? Hey, Maddie, did you go recently on screen?
Yes, not that recently though.
Okay, I know Alex and Lei went. Hiram, you want to take the screen? But you have that Linux setup or something, right? It'll take a while.
Yeah, I do. Wait, really?
All right, maybe Alex can take the screen again, or Lei or Alex, right? Most recently, I think I remember one of you taking the screen, but I don't know who. Right, the other one can take the screen, hopefully. Right. Let's open up an editor.
Should we do Replete or online?
Let's do Replete. Which was the one where we got the command line? I think it was
Replete.
Yeah, let's do that. Let's do that.
Okay, I can do it for like part of the class.
Yeah, okay, thanks. Hey, anyone willing to take over from, hey, Hiram, can you, in the next half hour or so, can you get your environment ready so that when Alex is able to transition, right, you can take your code?
I mean, the only difficult thing for me is copying the code out of it. I can make stuff like really quick. It takes me.
No, you can open a browser and just go to that Replete URL.
Oh, okay.
Hiram, do you want to do it first or second?
If we're using Replit, I don't really care.
Oh, okay, you can go first.
Okay then. Then I guess I will get a browser tab. Okay, I think I can probably share now.
Oh, it asks you to sign? Yeah.
That's weird. Let's not do that.
Yeah. Well, why does it ask you to? Well, no, there should be an
don't.
anonymous way to code, right? Without having to sign in.
No,
at all? Because lots of people have done that before. Start coding. Click start coding.
Yeah,
but that's what it did.
With Google.
Oh, it
And
did.
And I can. I'll stop
last,
sharing. I can stop sharing and log into my account.
Okay. All right. Yeah. Well, yeah. If possible, do that. Otherwise, we'll just go to online GDB.
Okay.
Yeah. Okay. So what we'll do is we'll create a bunch of arrays for our animal, right? And then see how messy it gets, and wonder if there's an easier way to do it, and then say, well, we can do it with objects, right? And then we'll say, okay, this is how we can change that into objects. I think that will be a good good way of introducing the motivation for objects.
Okay, I think I'm good now. There. That work?
Great. Is this? Oh, I see. You have a different layout. So Replete lets you have the console either on the left and right, or up and down too, right?
Looks like it. This is how it booted up just when
Because
I started.
I think last week when Lay was
it was definitely on the right, yeah.
Yeah. Okay. All right. Great. Okay. Let's put a comment. No. Yeah. Let's get rid of the main here. Get rid of the main for a sec. Okay. Yeah. Okay. And then rename this file to animal.cpp. Yeah. Rename the file to animal.cpp. Right. Okay.
Oh my
so
gosh.
now let's put a comment on the top saying there. Say. I actually don't know what to put in the comments, but I know what to put in the code, right? So let's fill out the code first and then put the comments in later, okay? So, all right. All right, so I think let's create a bunch of arrays here, okay? A bunch of arrays, global arrays, all right? See, this is global arrays. How do we do this? Well, not even global. Can you go back to your main? Okay, well, let's go to main and then come to this file. Okay, I think I skipped one step ahead. Just go to your main.
Okay. So we need another file that's main.
In your main, int main, yeah, usual.
Oh, just the normal main.
Yeah, create a new file. Yeah, main.cpp is good. I think that's what we were planning to do. Yeah, all right.
Oops.
Yeah, reload it, come back. It's just a JavaScript, right?
Yep.
All right. So in your main.cpp, introduce, create your main. We're not sure what to do. Yeah, int main, and then open, close. All right, here, let's create 3 arrays, right? Or 2, let's create an array of 10 strings, okay? So say string, open, close, right? And you may need using namespace for now, right? So later on, we can tighten up the code, right? At the top, you need, okay, great. The string, and then you're going to say, you want to declare animal underscore names, okay? Animal underscore names, open square bracket, and say 10, right? Shall we use, let's use vectors, okay? Let's use vectors, not native arrays, okay? Just use vectors. I think it's easier. Okay, vector.
I just used the bin shortcut, dang it.
Oh, and then you also need the hash include IOStream. No. Are you a Python programmer?
Huh?
All right, so it's not hash import, it's hash include.
Oh, dang it.
All right, IOStream and then vector also. Okay, change the vector. All right, I think that should do it. I think that should do it. All right, so in main, let's create an array, a vector of string of 10 of size 10. Okay, of size 10. Animal names of 10 names of 10. All right, now let's create the whole line. Triple click on the line and then right, one more time, triple click, and I pasted. Now and then let's say, right, so animal limb counts, right? Limb counts. I don't know, I got to get creative because this is exactly what we're trying to do in the quest also, right? That's right. So, all right. Oh, animal sound. All right. Vector of string, animal sound. And I think the previous one should be vector of ints, right? Vector of ints.
Oh, you're right.
Limb counts are ints or size t.
Oh my gosh.
Size t. Because it's not size t. Because it's not going to be negative, right? So you can't imagine an animal with negative size limb count, right? And I think animal sound. Okay. All right. So now what we're trying to do here is that we want to store, right? Let's say animal names of 0 equals dog, right? Animal sound and names are 0 equals dog. Equals dog, right? And then you say copy that line and say animal, and we're only doing the first two, right? Which is developing a motivation here, right? And then yeah, of 1 equals, I don't know, cat.
Equals cat.
Yeah, any other, right? Now do the same thing for limb counts, and then for animal sounds, you can
Keep doing freaking
yeah.
limb
Anyway, but
shortcuts.
anyway, you can stop right now if you want, right? But you can see where we're going with this is already starting to get rather messy, isn't it? Because what we're trying to do is that we have one mental idea of a thing called an animal, right? And it's got connected. So a dog whose attributes, the attributes of the dog are the name of the dog, the number of limbs it has, and I don't know, the sound it makes and so on. Everything is connected with a dog, but they're not all stored in one place. They're all stored in different arrays. And the thing that's connecting all of them is just the array index, right? So if I asked for what sound does a dog make, right? You've got to look in the array, sounds of 0, because 0 is where all the dog things are stored. And it's starting to get messy. Isn't it starting to get messy, right? So what we want ideally is to not to have, this is called a parallel array implementation. Believe it or not, there are some situations, despite having objects in C++ and other languages, despite having the ability to use objects and package things together like we're going to do, it is beneficial in some places to actually use parallel arrays. Now, parallel arrays are arrays that are connected by index, right? So meaning that there are two different arrays, maybe stored on even 2 different machines halfway across the world, right? But they actually store related data. And how are the data related? They're related because the index here corresponds to the same index there, right? So they're called parallel arrays, and parallel arrays are basically a headache to maintain, right? You can think of it already, right? Because you got to make sure that first of all, they're both the same size, right? If one of them has one more item, you're basically screwed because you're going to access an out of bounds item on the other guy. Yes. So, and then if things change, you got to make sure everything changes. If you change the index of one item here, you got to change the index of the item in all the other arrays too. Yes. If dog moves to index 5 here, all the dog attributes have to move to index 5 in all the other arrays too. So you can see how painful it's starting to get already. Okay, so what we want conceptually is not to store them in parallel arrays, although there's a time and place for doing that. What we want is to store them all together, right, in one bag, right, and have an array of bags. Does that make sense? Okay, so this bag concept is what we call one of the motivations for objects. Okay, but believe me, this bagging concept is not unique to C++. It was there even in C, right? Even in C, the struct idea is basically a bag, saying here is a struct, a chunk of memory into which you can put lots and lots of stuff, and then they'll just carry, together. So you can copy a struct, meaning all of that is copied together, right? You can have an array of the structs. So all of that was already there in C. So what C++ brings in addition to the picture is that not only can you have a bag of things, right? But inside of this bag, you can tell the external world that this bag only has 2 things in it, or you can only see 2 things in this bag. But in reality, right, this universe has 99% dark matter that you can't see, right? Which is necessary for me to maintain the 2 things that you do see. Does that make sense? So that is the power that C++ brings to bear, is to say that I will now give you a feature which in fact does not seem like a feature on face value, right? It is not like the ability to pack things together. I'm just going to give you the things to hide things from other people, right? So basically I'm going to give you opacity, which you can use as a tool, right? So that's the only thing that, object orientedness brings to the picture. And that once you grasp that, I think a whole lot of things in C++ becomes really easy, because you know what you can manipulate inside of the object and what you need outside help to manipulate, right? So that distinction is, is very useful to cut big code. And so the first motivation is to put things together in a bag. And the second motivation is to say, right, this bag contains a whole lot more than what you can just see, right? I have other stuff that are private to me, right? This bag has a whole lot of methods for dealing with the things that you can see, right? But you cannot mess with those other methods, which are control methods that I use, right? Does it make sense? C++ lets us do that, right? So it defines this whole idea that some things in this bag can be private and some things in this bag can be public, right? So these two keywords are private and public. So in this bag, you can mark certain things as private, saying they're not visible to, snoopers who want to know what this bag contains, right? But public means that this bag does actually contain stuff that you can use. Take it, okay? And in fact, you can also make them as public const and public, right? Const means I have something that anybody could read. Public, const, public, right? Anybody could read, but nobody can change, right? It's like a billboard on 101, right? Everybody can read it, nobody can change it. And well, one person, right? The owner can change it. But const public, not const public, right? Regular public means people can basically just, it's like, a chalkboard on, outside a restaurant. Anybody with a piece of chalk can go and, scribble on the menu, right? So it's like that. So public can also be marked const, just like you play around with variables and things like that, right? So you can bring all of those to bear. Just as one, and we'll see how this one feature lets us make more powerful programs, right? And the irony of C++ and object-orientedness really is that you give more power to programmers by taking power away, or freedoms away, or willingly, right? Programmers willingly say, I don't need this anymore, right? I don't need this freedom anymore. I'm moving on to bigger things. So so C++ says, as a programmer, you'd say, I don't need these freedoms. I'm going to stick by these rules because that's the way I can get to where I want, right? So, and because I'm going to stick by the rules, these freedoms are useless to me. The freedom to step outside these rules are useless to me. So I'm going to stick to the rules. So the freedoms that you gave me to step outside those rules, I'll use them here instead of here, right? So you use the same freedom, but at a different level. And so it's not like C++ constrains you from, or any advanced language, right? Constrains you from doing what you want. It just says, it's what you asked for, right? You willingly said this is what you want. And all right, so let's change this into what we can say is now not composed of one object living in 3 different places, like Voldemort's soul, right? So it's 7 different places, right? So no, not like that anymore. So we want one object to live in one place, okay? So let's just go to main, and at the top of main, paddle, not paddle, sorry. You can change that to paddle, and you can leave, and you can comment all of those things out now. So we'll try and do the same thing.
Wait, how do you spell that?
Yeah, paddle, P-A-R-A-L-L-E-L. Yeah, parallel, I think. Yeah. I actually put 2 L's there. I don't know if it redlines it, and then space. Oh, it doesn't do spelling correction here. All right, now let's try and put a comment at the end of lim count, line 22, right? Line 22, put a comment there, line 22. I say, have a comment. Let's try and do the same thing using the object technique, right? And put a blank line above that too, so that we're going to try and do the same thing as above using object notation. All right, so under the comment, let's do it, right? Thanks. Right, so let's do. So let's say a class, yeah, space, the class, space. Let's call it animal, A-N-I-M-A-L. Space, yeah, curly brace. That is how you define all the things that go inside of here. Okay, yeah, enter, next line. And you say string name. No, just say semicolon, because now we're not creating the object, right? When you assign something to the name, you're creating the object, yes? We're not creating the object. We're just saying this is what the object looks like. So this is the definition of the class. This is a class, not the object. Is everybody, yeah, all on the same page here? 2 distinct things. The class is how the class is the blueprint, right? You can live on a blueprint of house. right? However, the house itself that's been built off the blueprint, you can go and live in it, right? However, you can go and change the house. It's not going to change the blueprint, right? Because you only change one particular house that's built off the blueprint. Yeah, it's exactly the same, classes and objects. Okay. All right, string name, what else do we have? Yeah, I think string sounds. Yeah, string sounds. And then I think we have size t lim count, right? Lim count. Right now they're all singular too, not plural, right? Because we don't have parallel arrays, right? Now we factored, in fact, you think about it, right? Even in English, we've actually factored out the plurality, right? Now what we're going to do is on a semicolon right there, semicolon right there. Yeah, okay, semicolon right there. On the next line, you're going to say a vector, okay, open angle bracket, animal, right? A close angle bracket, space, right? Animals, right? Now you took the plural from all the limbs and all these guys and stuck them to the animal itself. Animals, right? Of 10, semicolon, right? Now, we basically said, you know, we have a vector of 10 animals, right? And each animal has a name, and so all of these things are grouped together. Now it's really easy, right? Now we can go on to the next line and say animals of 0 dot name equals, right? And then you can say dot name, yeah, dot name equals, I don't know, did you have a name up there in the previous code? I don't know, line 20, line 16 maybe.
Diff. Okay.
Yeah, well, you know, it's kind of funny. We said it animal.name, and I was kind of expecting something like John or Joe there, but we actually said it's the yeah, maybe we should say animal.kind or animal.type. I don't know. You can decide. Okay, this is just, we're just playing around with code. All right, so do the other things too. Do the other things also. Is everybody following along? Right, I want to make sure that everybody is on the same page and understanding this, right? Those of you who aren't here today, please try and reach out to these guys, okay? I know you guys get together on other media, so please try and get to these guys and let them know, right? Don't drop off classes week 6, and these are critical classes, right? Now, if you know, if Fernando or Yushin join on I don't know, Thursday, they're going to be totally you know, they would have missed a very critical class. We'd be starting with objects that, you know, and thinking about yeah, you understand what I mean? Because, and then there's a much higher chance that they will really, yeah, have not be able to succeed. So get in touch with those guys and all these other guys who are not even, you know, logged in, right? At least these 2 guys are logged in and, you know, not responding. But many people aren't even logged in today. So next week it's I keep forgetting. Madison was, you know, correct last time. This is clocks go forward or backward. I think we get an extra hour to sleep next week, right? So it should be easier, not harder. I think it's only in spring that, you know, students usually not make it in time for when the switch happens. Okay, right? Is everybody okay? So this is how now. However, so is everybody okay so far with what we've done? Because we want to take this one more notch up. Okay. Right, and then after that, I'm going to hand over to you. What time is it now? Right? Yeah, it's 9 o'clock. I'll hand over to you at 9:15. Okay, I'll hand over to you, and then 9:15 onwards, you can code. Also on Thursday, you can code. Right, it's the same thing that you start today. You can code on Thursday, and then we can do this on Thursday. Each one of you come up with your own animal files, and then we'll try and find out. Okay, which animal your animal is. Okay, without having to by asking it the right questions in our name. Okay. All right. So. Is everybody okay so far? We're going to take this one more step forward. Okay, so comment this out, but copy the whole thing and paste it into a next block. Okay, copy the whole thing. Let's do the same. So starting from line 25, copy the whole thing.
Okay.
Right? Not until, yeah, there you go. Copy that and then say, open a comment again. And say number two. Let's do the whole thing yet again with you know, with one more nicety, right? We're exploiting one more C++ thing. Let's let's do the same thing. Let's do the same thing. Yeah, right there, line 44.
Yeah, but is there a reason?
No. You were changing line. Oh, you put number 1 there.
Yeah. Sorry.
No worries. Okay. All right.
So what I'm worried about
line
is
44.
Everything
line 44.
has...
You want to say?
Okay.
Line 44. Let's do the same thing yet again, but exploit one more C++ thing, right? But exploit. Okay. All right. So here, let's just say animal class under class animal, and just say, yeah, private and then colon, right? Private and then colon under that.
Under this?
Enter. All right, private colon. All right, and then indent private in to line up with, I think, class, right? Because I think one of the conventions, which reads nicely, is that, you know, private and public keywords align with the braces, right? So I think that looks nicer. Up to you. All right, now try and compile it. It won't compile. Okay, it won't compile because you told the compiler that my animal has 3 guys and those guys are private, meaning outside guys can't access it, right? But you try to compile it and it'll say, hey, you can't change limb count because it's private. Okay, so that's kind of cool, isn't it? Now, 2 ways. There are 2 ways in which you can access these, right? One way is to say, I'm just going to open it up to the world, right? I'm going to take it from the billboard and stick it on a chalkboard by the roadside. Okay, so you can say it's not private anymore, it's public. Then people can access it. Yes. Okay, there's another way to do it, right? Because, you know, making it public is not a safe way to do it. Yeah, in fact, you can make it public const and say, okay, well, you know what? It's going to be public. Everybody can access it, but nobody can really change it. Which means that once it's const, even you can't change it, right? So it's an extra level of difficulty for you. So what you really want is a very fine-grained step from everybody being able to change it and you not being able to change it, right? So what you want to be is a guarded access to your variables, saying that this variable called number of limbs, right, is able to be modified by other people according to their whim and fancy. However, right, not any damn thing will do, right? Because this animal is a prime animal. And therefore, the number of limbs has got to be either 2 or 3 or 5 or 7 or 11 or 13. Anybody know why? This is, you know, right? Because it's a prime animal, right? It's a mathematical joke, I guess, right? So it's got a prime number of feet, okay? All right, so you can say, right? So if you want to modify the number of limbs for this prime animal, it's got to be a prime number, right? Anything else, I won't let you do it. Yeah, it's your animal, right? You're going to create an animal, right? So when you create an animal, you can create it any way you want. So let's say so I'm going to keep them private, not public, right? However, I'm going to give the public a way to set the name, a way to set these guys. So under the last guy, hit enter, right? And create 3 public methods, right? Yeah, colon and enter. Right now, these 3 are going to be functions, right? Functions that you're going to attach to this animal class. And these functions belong to the class, so they can change all the internal guys, right? So they're the mediators, right? This side, you have your class, and this side, you have the user, right? And here, you have your gatekeeper functions that are going to basically talk to the user and then take the user's request and do stuff to your animal variables. Are we okay with this so far? Then we can just go ahead, implement that, show you how it works, and then you're basically set, right? From that point on to play with objects, all right? So, all right, so let's say bool, right? So this is the reason we say bool, right? Bool space set underscore name. Okay, set underscore name, right? Open, close. Now you can do the other 2, right? Open, close. Oh yeah, string. I thank you, Hiram. Okay. All right. So semicolon there. Yes. Oh, you want to do the entire thing right there?
I don't know.
Yeah. Okay. Yeah, Hiram. So it's possible to do it right there. Okay, just do it right there. Okay, just define the function. Right, so all right, so Hiram is defining a public function that is part of the animal class, right? And the name of the function is set name, okay? Which already gives a very good hint to the programmer as to what it's supposed to do, right? There's no other way to set the name of the animal because the name is private. The only way to set the name is via the set name. But why do you have the set name function? Because set name function is going to check if name is an empty string. If it's an empty string, it is not going to set it. Okay, so in your set name function, you can say if name equals empty string.
Oh shoot.
Empty string. I think that works in C++. Yeah. You can also call dot is empty, but let's not worry. Okay, I think double equals thing should work in C++.
Okay.
I hope, right? I hope it doesn't do this silly pointer comparison and fail. We can check. Someone can check on Google or something. It does the equals operator in for C++ work when comparing with a string constant like that, right? Because if it doesn't work, I'm thinking it may not work. If I think it'll work, okay, we're going to give it a shot. Okay, if it is equal to a blank string, just return false right there. This, right? Now you know it's not a, now you know that it's not a blank string, so you can set name to this arrow name, all right? This name, this arrow name, right? Not this dot, right? Python and no, Java programmers put dot there. Now this is a pointer to the current object. I wonder how we can do this better. For now, forget about this. Just instead of string name, call it string the name, all right? Call it the underscore name. No, there, up on line 53, on line 53. No, not there, not there. Line 53.
Oh, sorry.
53. Yeah. What would you call it? No, not D name. T-H-E. D name. One of the conventions that programmers use when they want to use something called name, but you can't use it, right? They stick D in front of it. So now you can say if D name equals empty quote, empty string, then return false, right? Meaning the setter didn't work. It's good for setters to return a value saying you asked me to set something, but I didn't succeed. Yeah, it has returned false. And if you call a setter, it makes sense to check the value. If it returns a bool, to check to see if it succeeded or not, right? You can't blindly assume that a setter succeeded, right? Now you say name equals the name and return true. All right, is everybody okay so far? That is a classic setter, all right? A setter, that is called a setter. You can actually put the comment on top because it's it's going past the end of line. Under public, right? Under public. I think you can
Just a
put it
sec.
on under public.
The Zoom window is getting in my way.
Oh, I see. Okay, cool.
Under public.
Yeah, enter there. Yeah, put a comment there. Yeah, we like the setter to return a boolean so that we can tell if it worked. Yeah, fantastic. All right. So that's great. So that's how a setter, and then you can do a to do after that, right? Put an enter after that and say enter after that. Not after, yeah, after line 58. After line 58, put a couple of enters, right? And then say in 2 forward slashes and to do, right? Flesh out the other setters, right? Flesh out the other setters. All right. Now let's do the getter, right? The getters are really simple, isn't it? Because the getters don't have to change anything; they just have to return the value. So these are called getters and setters, right? In Michael Loseff's notes and some other programmers call them accessors and mutators, right? And even the text, I think what text do we follow? I don't know. One of the texts that we follow, they call them accessors and mutators. I never ever got used to doing that, right? Mainly because it has so many more syllables, right? And also, I think on most IDEs, you can just right click and say, get me getters and get me setters, right? It doesn't say, get me accessors and get me mutators. Mutators, right? So, and not only are they they're 3 syllables, all the 3 are long syllables, right? So you can't have long syllables. 3 long syllables is a bad brand name, right? So you can't, I think, right? Because, it takes longer cognitively to get through it. All right, so getters. All right, so getters, you can do your getters very easily, right? So you say a string get name, string underscore, get underscore name. And you can basically say return name, right? That's it, right? That's all. Now, however, one thing we can do here is actually get really, really cool about exploiting C++ features and say this method is not going to change the object, right? Anyone can call, get me the name of the animal, but by calling, get me the name of the animal, are you changing the name? You're not changing the name, right? So you can say, here's a method. You can feel free to change the method and all that, but this method has got to be constant method, meaning this method cannot change the object it is working on. You can read the object, but not change it, right? And you can do that by putting a blanket const right here after string get name, right? Just before you open there. Yeah, there you go, right? Space, yeah, const. That means the method can go in and change and cannot change the object, but read the object. Okay, it's really powerful because when you later on get to implement methods that work on really complex objects, you can be confident about uh, calling methods on certain objects because they're const methods, right? They're not going to go and change things for you inside the object. Because you have other methods that you may write that need to change the object, right? If you're, and things like that. So const methods are, this is the syntax, right? For saying that a particular method is const. I don't know how you do it in Java. Do you mark a method final or something like that? Right? I need to Google to find out. Right?
No, you don't.
Yeah, I've forgotten. But yeah, I can too. Right. So many times what people do is just put the getters right up there. Oh, there you go. That's it. That's it. Yeah, getters right there. Right. Yeah. And setters also like that. This is called an inline definition, not declaration. Inline definition. The function is defined inside of the class itself. Right. You get lim count. Now, one thing I want to before leaving this topic, you have getters, and you're going to do the other setters. Yeah. I think you know what? I think when it comes to doing your game, you should not return the get sound. You should not return the whole sound. I think. Right? I think in your game, no, here, don't worry about this for your game. I think when you give your thing to the file that you generate to someone else, what you want to do is just generate the first letter of the sound you make, right? So what sound do you make? And then the animal should say, I can't tell you what sound I make, but the sound I make starts with a W. So you got to ask a question like, what's the first letter of what is the sound that you make? And then the animal should say, and the response should be, the sound I make starts with a W, or the sound I make starts with a B, right? And then you say, well, what kind of animal are you, right? And then the animal should say, the kind of animal I am starts with the letter. So every time you can ask any number of questions. How many limbs do you have? I don't know. You can respond with, I have an odd number of limbs or even number of limbs or more than 10 or less than 10 without giving away the action. So you're going to define, right? Put a to-do item up there for your own game, right? For your own game, put a to-do item up there above animal, right? Above animal, right on top. Yeah, here. Okay, here. Define a whole bunch of methods, which for each one of your animal properties doesn't return the actual property, but return something about the property, which will allow the user to guess, right? Now, let's go to your, this is your animal class, right? This is your animal class?
Huh? This is in the animal class. We have another
class,
file.
right?
Yep.
This is your animal class. Let's say you want to define a single let's say, what other interesting things? Do you want to play with this on your own, or shall we just do the beginnings of this game here with Hiram, and then you guys can take over? If you guys want to play with this on your own, play around with getters and setters a bit more. We have time, right? We have Thursday too. We can hack this on Thursday. We can complete the game. I think it's a very simple thing, right? Which is what, oh, I see you have not generated the .o file and linked it with multiple things. All right, okay, good. All right, so let me show you that, okay? Let me show you that and then quickly, is that okay? I'll show you how to generate a main program with multiple object files and you can link them with, right? So, and we don't need this for now, right? I'll just show you create a brand new file called a.cpp, right? A.cpp. Just create a.cpp, right? And go to a.cpp and create a method called function, right? Function A, or function foo, right? Just call foo, right? Void foo. Yeah, all right, foo. That's fine. Now, in the body of this function, what the hell did I want to do? Yeah, we just wanted to have the same function in two different files. Okay, right. Now, here you want to say, in here you want to see out. I was born from a function called foo, right? Just say something like that. Call from function. Foo was called or something like that, right? I was born in a file called a.cpp. This is a.cpp. Yeah, not foo, right? A.cpp. All right, now copy the same file and call it b.cpp. This, by the way, is not part of CS2A. I'm just showing you how you can have your files split up into multiple projects, all right? And then your single main can link with an appropriate object file, right? And you'll find it useful, I'm pretty sure, okay? Is this B? Yeah, copy the
No,
same file.
sorry. It's being weird.
Copy, duplicate that. Copy B, all right, B, right? And then, yeah, and yeah, B. All right, now we want a main.cpp. And in your main, call foo, right? Call foo. Call, oh, I see you have a main and animal. So just comment out the entire animal.cpp, right? So we don't need animal.cpp. And
This is, we did it all in main.cpp.
I just commented all out.
Okay.
All out for now. Gee, I'm really concerned that, you know, when we leave this code in a mess, like other students like Agnes or someone who look at the code, they're not going to look at the code. Nobody's going to look at this code, right? Because we are basically just hacking into bits and pieces, and in a way that we ourselves won't recognize it next class. It's okay. As long as you guys are all on the same page, because it's not a huge class, as long as we're all on the same page, we'll just basically ignore this file, right? It's a very bad way to program, right? Because, you know, leaving trails and bits and breadcrumbs here and there, bits and pieces. What we need is a really clean slate. If you guys are okay with, you know, the instructional bit that we coded in animal.cpp and main.cpp, you just clean up the slate, right? Get rid of it. I just want to show you that other bit, which is completely independent of what we talked about before, right? I don't want other people to be confused. If you're okay with what we've talked about so far, just erase everything that we had so far, except a.bb, the two A and B, right? We need those two. Everything
Should
in main and animal.cpp get
Should I just delete everything in main?
Yeah, I think so.
Okay.
And also, if there's a way, get rid of animal.cpp, right? We don't need that anymore.
Yeah, I thought we were going to be using it, but we didn't need it.
All right, great. Now in your main,
One
just
thing I'm
call
worried
foo.
about
Just
is that
call
it's
foo. Just call
complaining
foo.
about my STD.
Oh, I see. Oh, I see. OC out and all. Just hash include IOStream at the top, right?
Oh my gosh, yeah, that's it. Cannot type.
Yeah, because it's just a, you know, instructional.
There we
right?
are. Well,
Yeah, blank line. Yeah, okay. So you have two files with two different implementations of the same function, right? So obviously you cannot link all the three of them together because main will not know which foo to call. It's got two options for foo, yes?
Yep.
You call it, right? Now, so just call foo there. Call foo, FOO. And you don't need the hash include vector even, right? So you just clean it all up. You have to delete. And in fact, you know, strangely enough, get rid of all of that and using namespace and everything, right? You don't need any of that. And instead, we can say we need a declaration to tell main there is a function called foo that will be provided to you, right? It will be provided to you. Don't panic. And you say that by right at the top, you say void foo, and it doesn't take any pointers, right? No, parameters, right? So, right. So by saying that to main, you're saying, okay, go ahead, compiler, don't complain. The code for foo will be provided. Are we okay with that? If we didn't do that, the compiler will complain, right? The IDE will say, hey, you're calling a function. I don't know what that function is. Everybody okay with that? Yes or no? Good. All right. Now go ahead. You should be able to compile all of it, and it'll complain, right? It'll complain and say, just compile it, and it'll say duplicate externals or something like that.
Yeah, multiple definitions of food.
Oh, I see. Yeah. Multiple definitions, right? So let's now do it step by step, like you would do it if you were, you know, a programmer in the bad old days. Okay. So the first thing we're going to do is compile just main. Okay. And the way you tell the compiler that I want you to compile and not link all the binaries together, right? Once you compilation is a process of taking the source code, which is human readable, and turning it into something that only the CPU can understand on that architecture. Yes. Yep. Yeah. Everybody should nod, although I cannot see all of you. All right. Okay. All right. So we're going to tell the compiler, just compile, don't link. All right. And we do that by saying this. Okay. So type G++ and hit enter. I want to see if they have it. Oh, they actually do have it. All right, let's not do
Yay.
CLang. All right, internally, I think CLang is probably linked to G++. All right, they probably use the same thing. Say G++ space -o main. -o main.o. And then space -c. Okay, I'll explain what these mean, right? Space main.cpp. Right, that means compile -c means compile only, not compile and load, right? Don't compile and then try to make the main executable. Let's compile, right? And then -o means put your output in a file called main.o, right? Now, command is it control A to the beginning of line. Control A, hit control A. Now hit control K, which should basically kill it and keep it. You don't have to remember this, okay? Just control K. All right, now hit ls-l and hit enter. I want ls. All right, that is the contents of the current directory, right? It's going to show you what so you can see that the current directory, current folder contains 3 files: a.cpp, b.cpp, which you created, both of them, and main. So 3 files that you created, nothing else in the directory. Yes, yeah, everybody okay? Everybody following along? Okay, now control Y to yank what you killed, right? Control Y. All right, this is what you killed, right? From the beginning of line. You hit enter, that should compile. Now it's compiled main.cpp into main.o. Now if you come up arrow 2 times and get the ls command one more time, right? Now you'll see that there are 4 files there, right? Right, and main.o, main.o is now in compiler in the CPU language, okay? In fact, if you look in the file, you can tell what the architecture is, right? Whether it's Intel or AMD and things like that. So that is now in machine code. The compiler has taken your main and translated that. And it's very small, right? Because it doesn't have a lot of information, it just calls foo. But at this point, there's no executable. You can't run it, right? So you want to repeat the same command. Instead of main.cpp and main.o, you want a.o and a.cpp.
Like that?
Yeah. All right. Now you do an ls-l, you should see your object file, right? Again, you got the machine instructions for foo from A, machine instructions, right? Do the same thing for B. So do an ls-l. All right, now you have all the object files, right? Now the compiler has done its job. You just want to link the appropriate things together. Now you can tell the compiler G++, right? And again, it's really not the compiler. G++ is just a wrapper. It's not the program's doing, it's calling other programs to do your stuff for you. You're saying G++, here is my mains object file, space, main.o, right? That's the first machine code, right? I want you to link that with the code for foo, which I promised main that I will give, but that should come from a.o, not b.o, right? So it's type a.o, space that a.o. And when you've linked the two together, made the binary for me to execute, take that and put in a file called space -o and call it main-1, right? Main-1. Oh, main-a. Right? So this is the A that is executable, that is produced from main with A, right? Hit enter, right? And do the same thing with b.o. Using the same main, but different objects. Yes, these are called different object files, right? Not different class object, right? Different, yeah. I don't know what to say. All right, now do an ls. You should be able to see 2 different kinds of executable files.
It's all on the left anyway, so.
Oh, it's all right there. Yeah, cool. I didn't even notice. All right, but you should be able to run. You should be able to run /main-a. It'll run the first kind of main, right? Yeah. So now you know, right? Now each one of you is going to go away and create your own animal.o. Now, is everything now falling into place, and is it making sense? Each person is going to create their own animal.o, right? So you're going to create maybe animal alex.o, animal maddie.o, animal hiram.o, right? So many different animal.o's are going to be there. Yes. Now we can create a file in main that just basically steps through some questions, asking what is your name, What is the number of limbs, right? And so on, right? 50 questions, 50 standard questions you're going to ask, and each one of them is when we link with Hiram's program, with Hiram's animal.o, each one of them is going to come back with an answer, right? A, 7, and so on. And then we all take, and the first one to call out what the animal is the winner, right? So maybe you don't need that many clues. Maybe you know what the animal is after five of those, right? Maybe, you know, number of legs, number of limbs, 8, right? Poisonous, right? Scorpion, right? Something like that, right? But other people may need to wait until they see the letter S, first letter off, right? So things like that. So you can turn this into a game. We can turn it. So each one of you, and you can share this on, don't share it on Discord, okay? Share on Reddit or here in class. Each one of you create, this is your task, right? You can get extra credit for this. Each one of you create your own animal, right? And someone come up with a whole bunch of questions, right? Interesting questions with, you know, name, is kind of animal, and you're not going to give out the entire name. You're just going to the first letter, okay? And then the sound it makes, number of limbs, are you furry, right? All kinds of things, right? Color of the animal. Can you fly? Can you swim? Right? And these are 50 questions like that, and then you just shuffle those questions, and then you're going to ask them questions randomly, one after another. To the and then Hiram's .o file when linked together and your program is run. Is it making sense? If you're not able to do this, we will absolutely get this all done in Thursday, right? On Thursday we can do this in class, but I hope we won't have to wait until Thursday. Okay, this is really a juicy opportunity. You can create each one of you create your own animal using some common question bank. One of you has got to come up with this question bank. Okay, already you have 3 questions. Right, but I think you should have at least 25 questions. And obviously, you know, can you swim? Can you fly? Can you walk? Can you run? And many of these can just be yes, no, right? I don't know. Are you vegetarian? Do you have claws? Right? Are you extinct? So it's just like 20 questions. Just like 20 questions, you're going to have all of these, and each animal has got to answer their own, right? And nobody will know because you're only going to share the .o files. Nobody will know your CPP file, right? Next class on Thursday, we will basically just get a zip folder of, I don't know, 10 or 15 .o files from different people, and then we'll have one main, which is just basically going to go through a bunch of questions, which all of you guys have implemented, right? Randomly chosen questions. And it's going to link with Maddie's animal.o, right? And then it's going to shoot up these questions one after another, okay? And then we hit the space bar to go from one question to another, right? And at the end of each round, we say, go on to the next question, or someone can take a crack, right? And if you take a crack and you guess the wrong animal, you're out. Right? And obviously, you know, since Maddie is the owner of the .o file, and she'll get the chance to say, all right, that's not my animal. You're out of, you know, it's like musical chairs, right? So the one who owns the animal.o file will get to basically, you know, say you're out or you've won. I think it's a nice little game. We probably have scope to turn this into a really nice game, okay? Next quarter too, and maybe even turn it online.
Well, are we each writing like a new animal class, or are we just?
Yeah, I think so. I think each one of you can write your own animal class, okay. And all of your animal attributes will have to be private. And obviously, you may need an extra attribute, right? You may need, for example, number of feathers, right? And which may not make sense for someone else. But I think in that case, you also have to come to consensus on what the, you know, attributes of the animals are going to be. Right? Like, you know, limb count.
So what I was thinking is that we could figure out that list, and then all of us
figure out the list and figure out the list of
attributes.
questions. Figure out the list of attributes and then questions. Attributes and questions, and then each one of you is going to create an animal which can answer all of those questions without giving away the actual answer, but only giving a clue in each one of your, right? And then we'll create a craft domain together in class on Thursday, which will basically go through your set of questions, your question bank, shuffled in some random order, and it's going to ask one question at a time, and then spacebar to go on to the next question, and so on and so forth. Okay, and we'll come up with some kind of nice interface. Okay, and then we can link in each one of your .o files and try and take a guess. Okay, I think it'll be fun. And if you guys are not, don't want to do animals, you can do other things too, right? It doesn't have to be an animal. It can be a, a man-made object. It can be a plant. It can be a place, right? Maybe, oh, is this in Antarctica? Is it in, Greenland or Ecuador and things like that? No, I don't know. Less people are interested in geography, right? Yeah, find something that would be, cool for everybody and do it. I think it'll be fun. Are you guys okay with what we've done so far? Was this useful and instructive? Yeah. All right. So this is basically just building the foundations of what a class is, right? Getting the intuition for a feel for packaging things together. But packaging things together already there, right? We are used to that. The real power is not only in packaging, but being able to conceal part of the package, right? By concealing part of the package, why does it make us more powerful? My theory is that it makes you more powerful by concealment makes you more powerful when you're just concealing all the rote automatic things that can be taken off and taken care of by automata, right? Freeing up your mind to think about more serious and consequential things. And I think in languages where which require you to do a lot of babysitting, you actually have to progress to a much, you have to develop a greater degree of discipline, right? To not do some simple mistakes before you can get really productive. Yeah. I think that's why you can get more productive quicker in languages like Java and Python, I think. Because a lot of these things are taken care of for you, so you can get more productive quicker. But it does help you to not have those things taken care of for you. When you get onto the, to do some really hardcore stuff, you want to say, okay, well, no, I hope you don't have to take care of these things for me now anymore, because I'm, old enough to do those things now, and in fact, I can figure out even faster ways of doing those things. Right? So that's when you basically say you're okay to take on some of the stuff that your parents have been doing for you. Okay, I think that's basically it. What time is it now? Holy cow! Yeah, it's you've got like a half hour. You guys want to play around starting now? My concern is that after this class, you basically just forget about CS2A and C++ until Thursday, right? Because then it would, right now, it won't help, right? For the next 2 weeks, you have to be mindful and constantly thinking about C++, right? Get objects drilled into our subconscious, and it'll be a whole lot easier. After that, you can take some, you can be slightly more freer. Are you guys okay? Can you guys go ahead and do the C++ class, and then I'm going to be around, obviously, like as usual. You can call me back if you need any specific questions answered. But this is it, right? These are objects, and we're yeah, I think getters, setters. We actually covered a lot of ground today, right? Because we did classes, public, private, getters, and setters, and also methods. We also wrote some methods. Methods are basically just functions you're attaching inside of objects, right? And how to call a method too, right? We said dot get name and dot. Did we call getters and setters in main? We didn't, right? Oh, maybe that's the only thing we left. How do you did we ever end up, I forget actually, did we call the setter that we wrote in main? We said we just created the setters and getters, right? We didn't call them. All right. Does everybody know how to call getters and setters, or a getter? You just say object dot. No? Do you want me to do that now, or are you happy just doing this on your own? It's up to you, right? I don't have any problems. Right, next class, maybe the class after that, we'll start thinking about certain more nice features of objects, right? It lets you have some static variables, right? Stuff that's written on the blueprint that people can change. All of those features are available. We can look at that starting next week. But for now, Are you? Do you guys want me to do it? Are you happy writing a main in which you can call getters and setters of objects, or do you want me to do it? It'll take about 5 minutes. We can write a main in which we can create, right? We can create a main in which we create an object and then call. Do you want to do that now? Right. If you want to do that, just go see. That's an object file. See, that's an object file because it's all machine code. It's all binary machine code. That's why it looks like that. In fact, by looking at that, you can tell what kind of architecture it is many times, right? But maybe not in this case. Sometimes this has, magic numbers at the top. And if you actually look at the hexadecimal values, you can tell. If you recognize the architecture, you can tell. All right. Anyway, I think I can delete those things. What are we going to do? Yeah, we can create a simple class, manual.cpp, some simple method right there. We'll do a really quick one. Yeah, you have it. You have it right there. Oh, get species. Okay, right. This is go to main. Go to main, and you say string species equals animal. And is it animal? We call it animal, right? Animal. Yeah, animal. My animal. Okay, animal, my animal. Right, my animal. Right, semicolon. Right. And then you say animal.get species, animal.set species. Did you have a set species? Let's assume you have a set species. Oh, by the way, why does it say underline that? Is it animal.h? Oh, it's animal.cpp. All right, just go to your main. Go to your main. The same way, just go at the top, you say class animal semicolon. Right, that's a semicolon. Right, that's just telling the compiler that animal is going to be a class. Don't worry about it now. Semicolon, semicolon. All right, that tells the compiler, don't worry about animal. Right, it's going to be a class. Why does it not? Mouse over the red line. Incomplete. Oh, it doesn't let you do that? Class animal. I just copy the animal definition and put it above main for now. All right. You don't, yeah. Put it above. Okay. All right. And then you can basically say C out. Well, I'll just show you what you do, and then you can figure out the rest. Okay. C out says, yeah. On the next line. What is this? Oh, I see. You want to do this. Yeah. String. Yeah, you can do the same thing. If it's not null, you can set it and return true. Is everybody following along, right? I know Hiram is just typing away, but you need to speak up, right? Just let me know. All right, good. Now you can say my animal.set species to, I don't know, mammal. Is mammal a species? No, mammal is not a species. And species have these weird names. Rattus raticus. I think Rattus raticus is the name of. Yeah, I'm going to think all the way back to my biology class from 7th grade when I was doing an earthworm, and I was amazed that what is the species name of an earthworm? Megascolex maruti. Someone should Google this and find out. I think it's called Megascolex maruti, right? That is the name. This is a species name for an earthworm, right? So Google that. Hey Google, what is the name of the species of an earthworm? Hey Google, what is the species of an earthworm?
Biological species frequently mentioned on the web include common earthworm, Icenia fetida, Lumbricus rebelis, and others.
Oh, maybe it belongs to multiple species. This is Megascolex maruti, Megascolex maruti. I'll find out. Just curious. Is everybody okay with this? That's it, right? So you just say on your main, you're going to say C out. What did it say? Int? It said what did it say? Int? Oh, you're just returning. Oh, I see. You're just rat. Okay, rat. Yeah. Okay. All right. So get species. That's how you set the species and get the species. Right? And your getter is const. Yeah. Cool. That's great. So one of the things you can do is after you do the set, you can also say whether set succeeded or not, right? So where you do the set, you can say if set if my animal dot set,
Right.
if my animal dot set, and then you don't have to say double equals true, right? Because it returns true or false. You don't have to say, many times people say if P equals true, if P, that's enough. Yeah, on the next line, you say set succeeded, C out succeeded. On the next line, you can say C out set succeeded. Yeah, and otherwise you can say set failed. In fact, what you can do is, if not, you can say set failed and exit, right? That is the usual way to do it, right? If you are not able to set it, then you can just say set failed and exit, right there. Yeah, if not, yeah, there you go. Set failed and exit. Failed to set. Okay. And then return right there, return 1. Because it's an abnormal return, so return 1. Okay. And -1 more, right? And yeah, enter. And then enter and then close the brace. Oh,
I forgot to put a brace in the beginning.
I have a question.
Sure.
So my animal, before you set the species, how come you don't have to do something like equals and then whatever you do to initialize the object?
Oh, it's passing the parameter rat. It's passing the parameter rat, yes? And in set species, where is your set species? Right? So in species, the species is rat, yes? So that rat is a string which is assigned to the species which is attached to the animal. So that animal species becomes rat from that point onwards.
Oh yeah, I understand that, but
Yeah.
Wait, wouldn't it be my animal's species becomes rat because it's an instance of animal?
Yeah, my animal is an instance, and then my animal species becomes rat from that point onwards. Yes.
It's not global.
It's not global. It's certainly not global. It is only, yeah. So in fact, you can have many animals.
okay.
You can have one animal species set to rat, and another animal set to worm, another animal set to bird, right? We should probably correct that, right? I'm pretty sure our biology instructors would be horrified to say that we said a species was a rat. But kind, all right. So you can have many animals, and each one of them could be a different species. And you say, that's get species and so on. But in fact, you can say set species to null, empty string, and it should basically say set fail. I think so. And we'll also get to find out if the double equals to a pointer actually works, in C++. Yeah, compile it. Now it should say set failed and run and exit. If not, then we have to do a different comparison. Or wow,
why does this take so long?
No, I hope we haven't. Right, kill that and run it again. Kill that again.
Well, it worked.
No, kill it again. Run one more time. I want to make sure it's not a network error. Why is it taking this long to fail to set?
I don't know.
Run it one more time. Run it one more time. Wow. Oh, maybe it's just main. No, you're compiling and running it. No, just run it. /main. Yeah, maybe. Yeah, just say
yeah, maybe.
/main.
There we are.
So, yeah, I was. So the reason I was concerned was because if C++, if the designers of C++, which I suspected not, okay, I'm pretty sure they would have, if they didn't account for the fact that C++ guys would compare a string to a pointer, because on the right-hand side is a native string. We talked about native strings last class, right? A native C string is just a pointer. It is not a string object. It's a pointer, and a pointer is just 4 numbers. It's an address. It's a memory location. Yes. It's a memory location out there, bam, like that. It's a pointer. And so C++, when the designer of C++, the authors of C++, right, when they created the equals operator that says, oh, the equals operator, here's a code that you're going to use to compare a string with another string. Well, sometimes this string may actually just be a pointer. But if that's a pointer, that's how you do it. Now, they can be clever enough to say this equals operator, you have multiple functions. Sometimes you may have to just do pointers to a string. Sometimes you may have a string to a string. So if they'd been intelligent enough to code both of, right, then we can safely do this. But I was concerned that maybe in C++, they didn't do it, right? They said, if you want to compare a pointer to a string, do it, the way that, a real programmer does it, right? Go all the way down to the nuts and bolts and do it on your own. No, fortunately, they didn't do it. Because if they didn't do it, then this array, this delay would be explained, right? Because that pointer is making that function do some really weird things, right? And maybe it's getting stuck in an infinite loop. And so that's the reason I was concerned. And maybe, maybe in all likelihood, we're running inside of a container, right? Even if we crash the machine, I don't think we need to care because we're just crashing a Docker container or something on Ripley. So, but still, you don't want to do that. Does that make sense? Is everybody okay now? That is, Lei, is your question answered? That's how you do a set, right? On a very specific object, right? Change one feature of one object only, not the other objects, right? Next, in a few classes from now, I'll show you how to change something that changes every object, right?
Yeah.
That's really cool, isn't it? Suppose you have a class and many people have objects of that class, but you are the owner of the class and you have a method that could basically change a property of every object out there that is an instance of this class. Isn't that cool? Right? So I can show you how to do that, okay? And then, you can find out how to do that too. You can find out how to do that. But we'll have an opportunity to play with that too in a few classes, not tomorrow or Thursday, right? Is everybody okay with this so far? Right? I think we covered too much material today because a lot of these things that we spoke about, I wasn't even planning to do for a week or a couple of weeks, but it's okay, right? I don't think any of this was unnecessary. What was it unnecessary? Any of this was unnecessary? No, okay. If it is, you should just let me know. All right, we can skip that and we spend more time coding. You guys can code, okay? And I can just sit around and watch. Are you guys okay now to take over, start coding? You can play, you don't have to do your own animal classes now, but you can play around with a group animal class and then come up with, in the remaining time, you can come up with a set of questions, a set of attributes. And then one of you, maybe Hiram, Alex, or Maddie, can make a list of these questions, right? List of these questions and a list of these attributes and say, okay, everybody go ahead and create your own animal. And this is the set of questions you should answer. And you can just call them question 1, question 2, right? Because otherwise these questions are going to, so ask question 1, ask question 2. And then, right? And then we'll know what those questions are. Because otherwise we'll spend a lot of time just, putting those questions into words is a pain, right? Question 1, you know what the question is, put the question in comments, right? Question 1 is going to be, what is your name? Or what kind of animal are you, right? And question 1 is always, and we can read a reference for now. And when in my main, I can do that, right? Question 1 is, I'm going to ask, what kind of animal are you, right? And then I'm going to call animal 1.question1, right? And question 1 is what kind of animal you are, right? And your question 1 is, you got to say, I am a kind of animal whose kind begins with K or something like that, or C for camel, right? So that is question 1. Right? And you can put a comment on top of question 1 saying, oh, question 1 should be what kind of animal, right? So that way you don't have to mess around with, what should I call my functions, right? So that's taken care of. The most time consuming part of your program is to come up with names for the variables and functions, and that's taken care of, right? Just call them question 1, question 2, and then you can call them, attributes. You can call them, I don't know, come up with names, right? You can call them name and color and whatever you want. Okay, so. So some of you come up with that, please do share it, okay? If you say we can wait until Thursday, I can tell you it's not going to happen, okay? Things don't happen. And then you'll come to the Thursday class and we'll do all this from scratch again. And just do it, right? Do it today, later this evening, do it on Reddit, or play around and share it. On Thursday, let's actually start playing with real animals. Okay, not real animals, but real animals that you created, okay? I think that'll be fun. You think it's possible? Do you think it's possible that we can do this on Thursday? Yes? All of you? Hiram, you were about to say something.
Well, so I'm trying to figure out how exactly we will do this. Like, the way that I'm thinking that we could do it is that in the class, we could just, I don't know, are we going to have setters and then have to set everything? We have to make a setter for every 20
No.
variables.
Yeah.
That just seems
now that you know how to do
excessive.
it.
I had an idea for that. You can have like a get my animal method in each of our files, and then we do the settings.
Oh, I see. Get my animal. And what is that going to do?
It'll return like an animal with the like species and extinct.
Oh, yeah. Okay. You can do that, or I'll just instantiate, right? You're going to create an animal class. Yes, each of you is going to create an animal class. So in my main, I'll just create animal, my animal. Now, when I link my main, I might link my main with either Alex's animal or Hiram's animal or Maddie's animal. We don't know. We'll just pick one of your animal.o's at random. I'm going to instantiate just like I'm doing now, right? Animal, my animal. I'm just going to do animal.myAnimal. And in my main, I'm going to say, right, I'm going to have a loop saying, ask my 50 questions in my while loop, right? Each time I'm going to pick question number 1, right? Animal question number 1, my animal.question 1. I'm going to call my animal.question 1. I'm going to call my animal.question 2, right? And I'm going to print the answer, and I'm going to wait to see if anybody has the answer, right? And then hit the space bar to go to the next question and so on. So some mechanism for the main we can work out. But essentially what I'm going to do is basically going to take your animal class, Hiram, right? I'll take your animal class, and just like Alexandria said, I'm going to instantiate a version, but I'm not going to do the Java singularity. What is it? Not singularity, singleton concept, right? Get animal or get instance of. No, right? I'm going to say, because that's what you do in Java, right? If you want a singular, what is singular object, or what? I don't know, what's it called? Singleton object. Singleton object. Yeah. If you want a singleton object, you have to get an instance of it, saying get instance, right? So let's not go down that road. We'll just say, I'll just instantiate the objects. I'm going to say animal, my animal, right? I'm not going to say animal, Hiram's animal, right? Or animal, Alex's animal. No. I'm going to say animal, my animal, animal, my animal, right? I'm not, so each of you doesn't get your own class name. Everybody gets to implement the same class, animal, with a capital A, animal. Everybody does their own animal.cpp, right? And all I do is instantiate your animal and call your methods, all of your 50 methods. Each of your methods is going to be 3 lines, right? It's just going to return one thing. So you're just going to write 50 of those methods. Right? Make them all public methods because I need to call them from main. And then we'll pick, each of you, all of your object files, right? We'll link in with the main, and we'll play random things on Thursday. I think it'll be fun, right? I can already imagine.
So wait,
we have a good time.
How will we create those animal.o files, the object files?
Oh, up arrow a few times where you compiled b.cpp without b.cpp with a -c flag.
I think that's gone actually. Oh wow, it isn't. Yeah, I remember that. It's just the problem is like, how does linking an animal, like, will we be using this and then actually using setters to set all the values, or should we set them right here, or what are we doing to make it?
Oh, I see. Yeah. Oh, we did. The 2 most important things that we didn't talk about, constructors, right? We didn't talk about constructors. What time is it now? Bam, 9:50. Right. The constructor is the part of the object that makes the object for you, right? It is a place where you actually set all the individual values of these guys. For now, let's just do what Hiram said. Forget about the constructor. In fact, by doing what Hiram is saying, we will build a case and a motivation for doing constructor next class, right? It'll take 5 minutes. But
wait, so we're actually gonna do all of this?
You're gonna do all of using setters.
Oh my gosh!
All right.
To create my own.
So I know. Yeah, that's right. When I say, that's what Alex was saying. Yeah. Okay, Alex. All right. When I say get animal, all right. Let's make it slightly simpler. Okay. I'm going to instantiate my animal. All right, using the usual animal, my animal, but I'm going to call Alex's method on my animal saying my animal.set values. Instead of saying get animal, I'm going to say my animal.set values, and your set values is going to set all the random guys. Is that okay? Is it like a midway house between what Alex suggested and what I'm doing? Yeah, yeah, that's good. All right. Hey, Peter's here. Hey, Peter. Do you want some snacks? Okay, come here. It's cold. Okay. Here. So I got him a whole bag of acorns. So he will take the acorns here. He prefers that to even walnuts. That is the craziest thing, because walnuts used to be his preferred food. All right. So is everybody okay with this? Everybody creates their own animal.o file. Okay. Good. So I'd like one of you to basically coordinate this, because if everybody thinks somebody else is coordinating it, nothing happens. So one or two of you coordinate this, make sure this happens. Something happens every day, right? Today, tomorrow, by Thursday, you actually have a whole bunch of animal.o files, right? Round up people who are not, sitting around not doing anything, get them to do stuff too, right? So ask your classmates to create their own animal.cpp files, right? You can walk them through, or you can show them your own file and say, these are the things you need to change, right? Create your own animal.cpp and give it to your classmate and say, well, change all the, attributes and then what you respond, right? So each one can do a different thing. So I would ideally like to have many of your animal.o files to play with next class. Okay, is that good enough? All right, I'm afraid, yeah, I'm sorry we didn't have too much time to play around at the end on your own. I just monopolized the whole class today, I realized. But next class, I promise you, we'll make up for it, right? We'll try and get to your coding as soon as possible, okay? And I'll just watch from the sidelines, okay, as you guys code. I'll just show you how to do this, Lincoln with a random thing. And then as you start coding next class, you can also try and make more tweaks to your program, right? Other things, other interesting things we can brainstorm and improve your animal classes. And we'll introduce more. And we'll talk about constructors towards the end of class, next class. Good. Yeah. All right. Was this class useful? Are you guys coming back? A few months. I think you guys are dropping off, but I hope you guys come back. Right now, I'm pretty sure next week you'll have more sleeping time too, right? So you don't have to feel us sleepy, right? You get one extra hour. All right. Good. All right. I'll see you on Thursday. Oh, you got it. It's Thursday, right before daylight savings. Please do come back on Thursday and hopefully come back with stuff that we'll be able to play with. All right. That's enough of blabbering on and on. Feel free to reach out to me anytime, okay? And I'll talk to you guys soon. Right, bye.
Okay.
Hey, Hiram, what's up?
Yeah, I still have honestly a lot of questions on how it's all gonna work, and that's sort of.
Yeah, sure. Yeah. In fact, it's good that so you can help the others too, right? Because if you have questions, yeah. All right.
So.
Good. You're going to create an animal
class. So are we going to make, so the way I understand it is that we're going to make this animal class that we're all going to use, right?
Yes.
And then in our own methods, we're going to make this main, right?
Yes.
Down here, we're all going to change this that it has a different my animal with different.
No. I'm going to write the main.
You're going to write the main.
I'm going to. You're just going to create the animal class. Get rid of the main. Get rid of the main. Get rid of the main in here. Right. Okay. This is your animal.o, right? Oh, in your animal.cpp.
No, let's go to the animal.cpp.
Yeah. So no main. You're just doing this. And here you're going to write Alex's method, right? So under public, you say set my animal attributes, right? So you say void space set underscore my underscore. Oh yeah, set animal attributes. And then no parameters. Okay. Now in this method, you're going to call a whole bunch of setters. In this public method, you're going to call a whole bunch of your own private setters.
Okay.
In fact, you don't have to call setters, right? You can basically set the values. This is a method, right? You can basically set. So let's implement this, right? Just go to the end and say implement this method right there. At the end, go after the semicolon. Yeah, enter. Right? This is a header file. Okay, it's a CPP file. Good. Right. So you say animal : set animal attributes. And this is void, right? So put a void right in the front. Yeah, put a void right in front.
Like this? In here?
Right in front of line 20.
At the very back?
Yeah. Because it returns void, right? It doesn't return anything. Yes?
Okay.
Right, this is what we declared, right? On line 17, we said we have a method called, oh, I see, you have the method right there. No, we're going to define the method outside. So yeah, so this is going to be out of line. No, you have the declaration there. Get rid of the braces.
Oh, okay. Oh, I get it. So we're just telling him that there's gonna be a set animal attribute.
Yes.
And then in our own thing, we're gonna make this.
Yeah, and you're gonna have to explain this to your classmates too.
Yeah, right? Yeah. I'll be posting this on Reddit, and so Replit has this really cool feature that I can actually invite people, and then they can either copy it or they can change it themselves.
Hey, cool. All right. Well,
So
we'll
I
do
could
next
do
class,
that.
next class.
Exactly.
Yeah.
So I'm thinking that I can send this join link instead because it says 50 people can join.
Oh
for
yeah,
free, so-
nice, nice.
So
All right.
we can just have everyone be able to edit it on top of being
Fantastic.
able to copy.
Fantastic. Yeah, and
So I
they'll all
think
be
that's-
edited in different places, and that's great.
Yeah. So, and that way we don't have to have like lots of different copies of it for everyone's computer. There's just one.
Exactly. Thank you.
So we're gonna have this set animal attributes, right?
Yeah, and
we're gonna
then
have all
here
of our
you're going to
getters
say, let's say string species equal. No, you say species. Species equals. Species equals. This is your animal, right? So you can say species equals, fish.
Fish, yeah.
Yeah, all these fish names.
0, like that, right?
Yeah,
So
yeah,
all
like
of that kind of stuff.
Each
So
one,
that's-
each one
and
will
then
have a.
you're
Put
gonna
a comment
call
there so
this-
that people know. On line, enter on line 19 and then put a comment on top saying this is Alexandria's method that everybody is going to implement. This is like Alexandria's method that everybody needs to implement on their own. And then also where you have 20 attributes. So it's not all the 20 attributes. You say all the attributes we on line 9, on line 8, you say this is a list of attributes that we guys decide our animals will have. Decide our animal. Yeah. All right.
Okay.
Now you're going to set all the attributes.
We don't need, and we are gonna need to write all the getters, right?
Yes. All right. Let's.
But we're not gonna need to write the
getters.
setters.
Let's do one sample getter. Okay. So
Yeah.
let's say under public, you say.
Let's do the species. Let's do the species.
Yeah, get species. Yeah, get species.
But it's not going to be a single line, so okay.
No. It's not going to be single. No. In fact, no. We're going to do it separately, out of line. Everything will be out of line because this is going to be. It's not going to return a species anymore. It's going to return. It's not going to return the answer. It's going to return a part of it.
Yeah, but why can't that be in line? Because like,
what I tend to do is that anything that is not so trivial as to return a value that's already there, if it involves computation.
Okay, so you don't like it being inside.
No, you can have it inside, but I'm thinking that if you have an intuition that the method is going to get more complex eventually.
Is it going to be? Are all the getters going to be different for every person?
Yeah, they're all going to be different, and because you may decide that for a number of limbs you're going to say whether it's even or odd. Another person might say when asked for a number of limbs.
I get it. Okay, now I understand why you want it to be out of line. Sorry, I was thinking that the getters were going to be the same for everyone, but that
no. So we'll find out. In fact, we'll get a very good idea as we implement this. We'll have a very good idea of what.
So should I keep the const here with the?
Yeah, keep the const, and then
just like that.
Yeah, that's it. All right, and now let's go to the get species. Right? You say string get species. String.
Oh, right. Yeah.
And all of our getters should return strings. Even if I ask for a number of limbs, it should return a stringified version so that the main doesn't have to worry about the return type. Okay.
Okay. All of these need to be strings. I'll type that out.
So get species, and then put a comment saying all getters need to return strings, regardless of their actual return type. Right? Put a comment above that saying all getters do need to return strings.
Oh my gosh. Need to return strings
regardless of the return type. To make the main's job easier, because we don't want people to think that it's C++ restriction, right? To make the job easier in main, to make the job easier in our main.
Yeah, it was multiple lines, so I'm gonna.
Much better. I was actually thinking of suggesting that in main. Right. Okay. All right. Now, in our getter, we'll say, don't return the entire species, but say, return a string that says, my species name starts with the letter. Right? Do not return, but a hint about it. Okay. And then on the next line, you say return, and then say string, open parentheses, right? Within quotes, you say, my species name starts with the letter.
Oh, wait, do we need this?
Yeah. No, yeah. My species name starts with the letter. Everything was fine. No, you need to just say string because you're saying, do we need the string qualification? Can you just do quotes? Yes. Okay. Unfortunately, you can't do that in C++.
Oh, really? Okay.
Because if you use quotes, I told you that it's a pointer, right? It's a pointer is a number.
Oh, okay.
If you do a number plus a number, it's just going to do the number addition. But if you turn one into a string, then say, oh, I can add a string to a number. So this should be turned into a string. Okay. So all those complexities.
Then how do we?
Plus is after that. You say,
Oh,
no,
so we
not that.
can.
No, you can't add it to a. Now take the string and add to the string, right? Plus, yeah, string. No, not string. You say species of 0. Species of 0. Square
Wait, do we
0.
need? Oh.
All right. Now the
Why do we
plus
need it
operator.
to be of 0?
That is the first character of the species.
Oh, right. Yeah. Okay. Thanks.
All right. Now you can put a comment there for people who don't. Yeah. First character of species. Now let's do the same thing. A similar kind of hint for a number of limbs. Okay.
See. Will be pointer. Species 0 is first character.
Okay. So let's do another one for getter for get number of limbs.
Sure, that's fine. Okay.
Get number of limbs.
String.
Oh, you have legs instead of limbs?
I don't think so.
Oh, you said num legs equals 0.
Oh, I did. That's wrong. It should be limbs.
Okay, change the limbs on line 24.
Yeah, I will. Just a sec. Okay. This is.
Oh, why didn't it redline it? Because if it was not a variable that.
No, because the entire thing is wrong. I
Oh,
wrote
I
it legs
see.
here, but it should be limbs.
I think that's it. Okay. Yeah. All right. So now get num limbs.
Why is this?
Oh, you need the declaration. You say.
Oh, yeah. Shoot, it's up here.
A triple click in. Yeah.
Get num limbs.
Okay. Now here you want to say my limb count. You want to return the string. Return the string. My limb count is.
Oops. My
limb count is right, and then plus, and then we want a string that says odd or even, right? So let's see. On the previous line, you say is odd. On the previous line, just go to the previous line. On line, blank line on the previous line. On the previous line. Oh, you want to do it right here?
Like that?
No, but it doesn't give you odd or even the words, right? So then you have to do
you're right.
tertiary, ternary operators now.
Yeah.
Right. On the
right.
previous line, you say string. Bool. Is odd equals is underscore odd equals.
Yeah, sorry. Is odd equals num
limbs. I think %2 double equals
%2 double equals 0.
Yes.
Wait, no, wouldn't it be 1 and then question mark? One question mark.
Oh, you want to make it a string right here? Right now it's just a bool.
Oh, you're right. Yeah.
Yeah. All right. So on the next line, on the string line, you can make it a string there if you want, but
it's fine to just do it here.
It will be more
right?
confusing to just students in general. No, you can't do string because a string of then it'll turn into a 1 or 0, because in C++, what we want to do is do your ternary operator right there. Open a parentheses, right? And you say is odd question mark. Right? And then you say true. Oh no, odd within. Odd. Space.
And then
colon E.
Right. Yeah. Colon.
Yeah.
Okay.
And obviously, other people may have different kinds of checks, right? They may check to see if prime or not prime. Yeah. And not everybody has to do. When I ask Hiram's animal, what is your limb count? You tell me whether it's odd or even. Right? Put a comment up there saying Hiram's animal tells if the limb count is odd or even. But maybe Agnes's animal would say if the limb count is prime or not. And then Maddie's animal would say if the limb count is divisible by 4 or not. Right? Each person could have a different kind of answer for the same question. Make your own. Each person could have a different kind of answer for the same question. The only constraint is that everything has to return a string. Yeah, hence, thank you, Hiram.
Okay.
Yeah, but you get the
Yeah.
idea, right? Did you get the idea? I'm willing to clarify as
Yeah.
much as needed. Yeah,
I
because as
think
long as you
I
get
get
the
it
idea,
now.
you can explain it to the others.
Yeah. So basically, what I understand is that we're going to have one animal class that'll be the same in everyone's, right?
Yes.
And this will all be one file, animal.cpp. And
Yes.
then we have lots of public things that aren't defined. They're all just going to be like get and then this attribute
Right. Yes.
with const.
Yes.
And then there's this one that's void set animal attributes. And that is where we are going to define all of our stuff.
Yes.
And that's the
All
one
the
that we
public
changed.
methods you guys are going to implement
Yeah.
separately, not together. That's
Yeah.
your secrets. Those are your secrets.
Yeah. Okay. And then we're going to go and do all of these to get different hints for every person. So every person's going to have different things that return for their getters.
Yeah. And then
then
I'll
once-
run
Yeah,
your
and then go.
animal depending on your hints. The first person to decode what the animal actually is the
Yeah.
winner.
Okay.
Does this
That
sound like a
makes-
good game? I think it's like,
Yeah, that sounds great.
yeah, it sounds like a
Just-
cool
I
game.
didn't
Actually,
understand
nobody's actually come up with this game before. So it's, invented by CS2A.
Yay.
Yeah, cool. That's nice. That's nice. And maybe if this works out, I'll actually try use it next quarter too. Right? We'll actually use this next quarter. And hopefully, if one of you guys is free, you can come back when I teach this next quarter and say, "Hey, we did this last quarter. We're going to give you a dry run of that." That'll be fun, right? Students love that when seniors come back.
I don't know.
Yeah, if a prime number. So example question, example responses, right? From the example responses, people can figure it out, right?
Yeah.
So example responses and question. Some example responses to question to this. Some example responses to this question are right on the next line. On the next line after where you had the line before. Which one? Oh no, on the limbs thing, because I think we have more examples there, right? So on line 38, hit enter. Enter.
Oops.
Yeah, at the end of line 38.
Yeah.
Enter. Yeah. Say some example responses to this question are from other students. Some example responses from other students to this question are. Could be, not are, right? Could be. All right. On the next line, you say my limb count is a prime number. On the next line. My limb count is and it doesn't have to be in my limb count as like a variable. You can actually say it like an English sentence with uppercase M and I N, right? Yeah, my limb count is a prime number. Or it could say my limb count is an Avogadro number. No, some Sierpinski number, or and people have to go to Wikipedia to find out what's the Sierpinski number, okay? And things like that, okay? Some weird ass things like that. Or you could say my limb count is divisible by 4. My limb count is a special number. My limb count is a perfect number, right? My limb count is all kinds of things like that, right? It's a holy number, okay? It doesn't have to be, it's just things to have people start, hypothesizing things, right? And coming up with a Fibonacci number. Yeah. Like that. Anything that people can come up with. Right. In fact, if people are bored, they could even say my limb count is a nice number. Okay, so nobody knows what a nice number is. So you can say things like that. Okay. Yeah. All right. Cool. You can do all these things. Great. Is everything clear to you? Right? If it's clear to one person,
I think it's pretty clear to me.
If you have any questions, if someone asks you a question and you don't know the answer to it, you should feel free to reach out to me at any time, right? If you send me an email, I can usually be on top of the email within like 5 minutes, unless I'm in the middle of something, right? So I will get back to you soon, so you can get back to the students and
I will delete this from the main.
Yeah. Go ahead, do whatever you need to do. Share it with the other classmates, and make sure you get in touch with as many students as possible.
Should I? No, wait. I should just copy everything except these.
You can put a comment there saying this is the part that you guys are going to. Each student will respond, replace with their own. This is the part that each student will need to replace by their own. Yeah, and then where you say this is Alex's method, you say this might be, this might be, for example, Alex's method.
Oh, yeah. We were saying that because Alex suggested it, but
Yeah.
that's
Right,
confusing wording.
Oh, you could say, you know, for example, this is the method that Alex suggested in class, or something like that.
Eh,
And in this
I don't
method,
think
you're
it's
going to set
necessary.
all of the attributes for your.
This method sets all the attributes for your animal. Okay.
Yeah.
You need to make all of the getters on your own. They should be different from everyone. They should be
For
unique.
each person.
Unique.
Unique, yeah, and fun, right? And return, yeah. What do you say? Fun. Return something that not return the actual answer, but return a hint, return an interesting hint about the answer. And if you don't know what to return, you can say, you know, you don't have to return something interesting. You can say, you know, my name is a nice name. That's it. Right? I'm a nice species. If you don't want to disclose anything, you can say for example, right? If for snakes, for example, if someone says, what kind of an animal are you? And you say, you don't have a choice and you have to say snake, but you don't want to because it's too much of a hint. You can say, I'm sorry, I'm just a nice animal. So if you feel your hint is too strong, you can just say, write a comment saying, if you feel your hint may be too strong, you can simply return, I'm sorry, I'm just a nice animal.
Be too strong.
You can just return, I'm sorry.
Just return something
Something like, I'm
says
sorry.
nothing about your.
Yeah.
Like, I'm sorry. I'm a
nice species.
just a nice species.
Yeah. Okay, cool.
Okay, that should be enough documentation there, and then that's a little more specific. I hope they read all this.
Yeah,
Okay.
I hope so too, right? Because it's scope for
Okay.
so many things, right? Are you extinct? Are you not extinct? Are you prehistoric? Yeah, all these things, right? So many things you can do.
All right.
So you can come up with a question bank, and people can just, you know.
Yeah. So the question bank is up here. That's all the attributes that we have. But
Oh,
we
you
need
should
to,
come
like,
up with more
fill those out.
attributes. You should come up with
Yeah, but like, since everyone can edit it, like, I'm thinking that we could, like, just wait until we have 20 attributes in here first.
Oh yeah, at least 20.
I'll
At
make
least
sure.
20 would be good. That's good.
Yeah.
Hey, cool. That's really cool. I'm looking forward to playing this game on Thursday.
Yeah, I'll try to make my Reddit post on this very detailed so that people understand what we're doing.
Fantastic. Thanks, Aaron.
Yeah, it's fun.
All right. Okay. I'll see you on Thursday.
Bye.
All right. Bye.